welcome to Pomodoro Joe for Friday, October 20th, 2023. Today we're looking at LeetCode problem 341, Flatten Nested List Iterator. This is a medium problem. Whoa, it's a long one. So, we're given a nested list of integers, nested list. Each element is either an integer or a list, whose elements may also be integers or other lists. All right, so we're given a list of either lists or integers. Now, let me back up. So we're given a list, and each element in that list is either an integer or another list. All right, implement an iterator to flatten it. All right, implement the nested iterator class. So the nested iterator will have an initializer, which will be passed a nested list. Then we have a function called next that returns an integer, and we have a function called hasNext, which returns a boolean, so either true or false if there is a next. All right, your code will be tested with the following pseudocode. And if the result matches the expected flattened list, then your code will be judged as correct. Okay, cool. Now, one thing I note, all right, so nested list has at least one element. All right. Now, one thing that's interesting over here, we're past this thing called a nested integer. So, interesting. In Python, you could probably just pass a regular list of elements. In here, we're past this list of nested integer types. And the nested integer type has three functions on it. It has an isInteger, which will return true or false if it's an integer. It has a getInteger, which returns the integer if it is an integer. And it has a getList, and it will return a list if it is a list. All right, so this nested integer thing, this class, we get a list of these nested integer types. Now, for each one of our elements, it is a nested integer type, and we'll have to check if it's an integer or if it's a list. And then we have to actually unwrap it by calling getInteger or getList to give us back the actual integer or actual list. This is complicated. All right, so we'll put 25 minutes on the Pomodoro timer and we will get started. So I think I'll just do the simple thing. So I used to work at a company where our unofficial motto was do the simple thing first. So I'm just going to do the simple thing first. And the simple thing here is let's just take this list that we get and flatten it like right away. We'll just take this sort of complicated list of lists and integers and we'll flatten it into just a list of integers. And then when we call next and hasNext, all we have to do is just return the value at our flattened list index. So let's do that. So let's see. Internally, we'll have a self.flattenedList. And for now, I don't know what this is. So I'm going to create a helper function called getFlattenedList, or I'll call it flattenedList. And it will take this nested list. All right, so we have our flattened list, and then we'll have to keep track of what index we're at. So self.index equals 0. And I think that's all we need for this. All right, I'm going to come back and do this flattened list at the end. Let's just move on to the next and hasNext. Assuming this all works, this flattened list, assuming that works, for our next, we get the value at self.flattenedList at our current index, so self.index. And then we need to advance our index, so self.index plus 1, or plus equals 1. And then we return our value. So that is our next. Now for hasNext, let's see, I guess we have to make sure that we're still in bounds. So we can return self.index if this is less than the length of our self.flattenedList. Then we're still in bounds and we'd return true. If it's not, we return false. Okay, so that handles 3 of our functions, or 2 of our functions. Now we still need to handle this init. All right, so this flattened list. So let's create a helper function for this. Let's see. I'm just going to do it internal to the init, although you could put it anywhere. Well, not anywhere, but you could put it outside if you needed to. So how does our flattened list function work? Actually, I'm going to put it outside. Let's do this. Putting it outside is actually more complicated. I'm debating whether or not I should do this to show you how to do it. Let's start simply. I'm just going to put it in the init although you probably won't generally want to put this in the init. All right, so this is just quick and dirty. This is probably not great for actual code, like production code. So we'll have our input list, or I'll call it n list. This is our nested list that we're passing in. All right, so we're going to make this a recursive function. So our flatten list function here, I'm going to put the little underscore here. All right, so our flatten list function will return a result, and our initial result will be an empty list. So this will return our flattened list, so it will be an empty list to start with, and we'll return our result at the end. Okay, so now we have to go through every element of our input list. So for element, in our nested list, or our n list here, let's check to see if this is an integer. So if element, now again, this is a type of nested integer, so we actually have to call isInteger to see if this is an integer element. So isInteger. So if our element is an integer, we're just going to add that element, or our integer version of that element, to our result. So the result, append, here I'll do it in 2 steps. So we'll say the value of this element is element.getInteger. Again, the element itself is this class, this nested integer type. So I need to get the element out of it by calling getInteger. So element.getInteger, that's our value, and we can just append this integer to our result. So result.append this value, and then we'll move on. So I'll just continue at this point. All right, if it is not an integer, that must mean that this element is a list. So I'll call value here. Let's get the list out of this element. So element.getList. So we're going to pull this list out of the element. Now this list could be another nested list. So at this point we need to call flatten list on that list. Okay, so just so I'm clear, this value is now a list, but that list is also going to be a list type nested integer. So we need to call flatten list on this list. So I'll call this flattened list. That's going to be a recursive call to flatten list on this list. All right, now that that list is flattened, now we can extend our current result, or append that whole list to the end of our current result. So that's going to be result plus equals this flattened list. All right, that's just going to extend my result by this flattened list. And then at the end, we return our result. All right, so I think we might be done. We will flatten our list. We'll store the flattened list. We'll keep track of our index. And then every time we get a new value, we'll advance our index. And hasNext just checks to see if our index is within the range of 0 and our flattened list length. Okay, let's run this and see how we do. Seems to work. Let's see if we can pass all the tests. All right, and we pass. And we do okay. We actually do really well. We beat 87% for runtime and 64% for memory. So yeah, we do really well. Now we could do one thing really quick. It's the trade-off of memory and runtime. So this length, we're probably calling hasNext a lot, or they're probably calling hasNext a lot. So we don't need to recalculate the length every time. So one thing we could do in here is once we get the flattened list, let's just store this. We'll call this self.listLength or something. That's just going to be the length of our flattened list. And then down here, instead of having to call this length function every time, we'll just check our stored value. Is the index less than the list length? All right, let's see if this still works. Still works. Let's see if this gives us any advantage. All right, let's see. Looks like it's about the same, 87%, 87%. It does take more memory though. So we actually do better with our first solution just because of the memory situation. All right, So let's just go back to our first solution and we'll just go from there. All right, is there anything else we could do? I'm actually pretty happy with the solution. I mean, 87% is pretty good. We could probably cut some corners to make it a little bit faster, but I'm actually pretty happy with this. So I think that's it for me. In this one, we just took this simple approach where as soon as we got our list, we just flattened it right away. We stored that flattened list in our class here, the nested iterator. And then for our next and our has next, all we have to do is just go through our flattened list. All right, well, that's it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. And I hope you can go out and write better code.